1, 2, 1, 2. Can you hear me?
Yep.
I can hear myself. Cool.
Disconcerting feeling of hearing your own voice,
Uh-huh.
amplified.
Actually, let's take this off.
You plan on walking around a whole bunch or mostly staying by the laptop?
Mostly there.
Okay.
I will not cross this line.
Fair enough. Well, if you're willing to commit to the more static position, then you can do more zoom once you can start whenever you're
All right. Hello, everyone, and welcome to the Leaky Database Abstractions talk. In this talk, I will show you how unreliable complex abstractions may be, why this happens, and what you as developers can do to guard your applications from those abstraction leaks. But before we dive into the details, let's recap what this all is about. As engineers, we like comfort. We like comfort of our workplaces, nice chairs, desks, and monitors. And we also try to maintain the peace of our mind. We don't like deadlines, we hate multitasking, and we want to be able to focus on one thing at a time. And abstractions is one of the tools that help us do that. Abstractions provide us the means to use with like simplified models of the rest of the world and focus on one thing. But unfortunately, that's an ideal case scenario. In reality, some abstractions are leaky. What it means is that besides giving us a simplified model of what they represent, they also make us think about their implementation details by exposing them. And those leaky abstractions are everywhere. Let's say our computers, they're good at crunching numbers, unless those numbers are too big or too precise. And how big or precise numbers they can crunch depends on the computer. And the same is everywhere else in any software domain, like operating systems, file systems, networking, the leaks are everywhere. But in this specific talk, I want to focus on general purpose database abstractions, which is my personal pet peeve. And here's why. I started my engineering career as an enterprise software developer that was working with relational databases. In 2016, I contributed a few bug fixes to Doctrine DBAL as part of my paid work. And within a year, I found myself being a lead maintainer of Doctrine DBAL. At that time, within a few years, like I released Doctrine DBAL 3, which was the first major DBAL release within a decade. And soon enough, I'm hoping to release DBAL 4. Besides those kinds of abstractions, I also got exposed to a tool called Debezium. It's a different thing than Doctrine DBAL or ZenDB or whatever other things like that. It's a tool for change data capture. What it does, it connects to your database as a listener and can stream all transactional changes from the database into the outside world, let's say to Apache Kafka. This way, it can integrate your legacy system or a purposefully designed system to something which is not PHP, which is not relational database or anything. And as it's designed, it's almost magic. It can work not only with relational databases, it can work virtually with everything. So it's an interesting experience in terms of designing something extensible and robust. When I was preparing this talk, I was really thinking that specifically DocTrinityBal and all the database abstractions I dealt with are really leaky, and I tried to quantify my frustration about them. So I came up with a couple of metrics. The first metric is that almost every third issue or pull request on GitHub about DocTrinityBal, which is not about documentation, CI, or code style or anything, which is about specifically its APIs, it's related to a given database platform or driver, which means that if it's a bug, it's only reproducible under certain circumstances. If it's a pull request, it means that somebody wants to implement a feature that will work only with this specific driver or only with this platform. So it's either an existing leaky abstraction or somebody wants to implement one. So, and to me, this is quite a high number. The other number is that if we look at our integration test suite, something that tests the code from the end user's perspective, there's only a half of tests that actually pass on all 4 major database platforms: MySQL, Postgres, Oracle, and SQL Server. The rest of the tests are skipped because this database doesn't support something, that database doesn't support something else, and so on. Which again, from the end user's perspective, if they use this API as it is documented, it will just not work. That's also a high number. So given that specifically DocTrinityBal, and I believe for that matter other similar abstractions, are quite leaky, let's see why we're using them at all. Maybe we could just write plain PHP and SQL code and be in full control of what we're doing. So the first idea of why we may want to use them is code portability. If you develop a software product that your customers will run on their infrastructure, you don't want to lock them in a specific database platform. For instance, your product supports MySQL, but they want to use it with Postgres. Both are equally well known and adopted, and they have all their pros and cons, and you cannot really make this choice for your customers. So you have to support at least a couple of them. And in the past couple of years, even SQLite, which is not always considered a real database, it gains traction and it gets more and more used in production, even in high load, like scalable scenarios. So you have to support something. Besides that, if you're lucky enough, you may have enterprise customers who will come to you and say, hey, we will give you some money for you to implement the support for IBM DB2. So you have to be prepared for that. But what if your product is not the software product? What if it's a service? What if you don't need portability? You have already made this choice. This is what your code may look like if you do not use any abstraction. For instance, here's a simple function that fetches usernames of the user from a given group. So it makes a simple query. It binds the group ID to the query, and it fetches the first column. So to me, it's quite a lot of code. And the problem is that not only the amount of code and the number of keystrokes that you need to do to produce it, but also you need to learn and know all these APIs. And furthermore, it may be tricky to use them. For instance, this code prepares a statement, then executes it, and then binds a variable to the result. How do you even remember the order of operations? What will happen if you change the order of these operations? The thing is, if you change the order of the operations, it will work in most cases, but not always. So if you have to type this code on and on, you have to make sure that it's well tested, well copy-pasted, and so on. It's really hard to manage. And furthermore, this code doesn't even have any error handling, just for brevity, because otherwise it wouldn't have fit on the screen. If you do that, you will really have a hard time maintaining it. For comparison, this is what the same code looks like with DocTrinityBal. It's the same SQL query, but all the fetching, all the binding is done in a single method call. So it's not only easier to type, it's also easier to read. So it's a win-win at the cost of some loss of control. Like for instance, in this case, you don't have the statement at hand, you cannot reuse it, but most likely you don't even want to. So that's the reason why, the other reason why you may want to use a database abstraction. So now that we're more or less in agreement that database abstractions are inevitable, let's see where they leak. And here's a few examples from the abstractions that the doctrine DBAL provides. First one is the driver abstraction. What it does, basically two things. One, it allows to connect to the database and make sort of API calls to the database. The other, it is responsible for transferring data from your application to the database and back. And one of the features that this driver API provides is the connection last insert ID method. What it is about, it's usually used in conjunction with auto increment fields. So if you have an auto increment column on your table and you want to do an insert and you want to know what value eventually got auto-generated for that column, you will do an insert and then do last insert ID. So let's say you have a software product, let's call it a B2B product, that helps your customers manage gift cards in their product. So from the REST API standpoint, this API is stateless. So the client issues a post request to generate a new gift card, and as a response, it gets some details about that gift card, specifically its auto-incremented ID that your application has generated. From the application standpoint, there are two operations. First is the insert itself, which produces side effects and has the database internally generate that value for you. And the other, it makes a last insert ID call that actually fetches that auto-generated value. And that last insert ID doesn't accept any parameters because this operation is stateful. It's scoped to the connection. You need to use the same database connection for the insert and the other method call to get the results from that insert. And this is how simple it looks like in, again, doctrine DBAL. You do the insert, and you fetch the inserted ID. So you have built this product, prototyped it. You're aware that in order to have the broadest possible reach, you need to support at least a few database platforms. Doctrine DBAL supports all these three, and your integration tests pass successfully in all of them. Everybody's happy. So now you have an enterprise customer who comes to you and says, hey, can you support Oracle for me? You know that actually, yes, Doctrine DBAL supports Oracle. There are companies that run Oracle in production for years with Doctrine DBAL without any issues. So you give it a try. You try it with different drivers, and it doesn't work with any of them. And it fails even in different fashions. So you start figuring out what's wrong with that. Apparently, for those database platforms that do not support auto-increment columns natively, Doctrine DBAL implements a workaround. It uses sequences and triggers and makes the database generate them internally. But the thing is that for DBAL to know where to fetch the last insert ID value from, it needs to know the sequence name. And there is an optional parameter in last insert ID with that sequence name. So this sequence name can be obtained from another method call. You pass the table name and the column name to the method. It gives you the sequence name, and this is how you use it. So you add this extra line to the code, and the code starts working on Oracle, and it fails on MySQL and SQLite. Why is that? It's because they don't support sequences. So you now, as a developer, need to make a choice, like how to make them all work together. There is really a non-straightforward path to the code like this, but essentially what it means is that you need to check if the platform uses sequences to emulate identity columns, and if it does, then you pass the sequence name. If it doesn't, it will work without the sequence name. So if you write your code this way, all your tests pass on all your supported platforms. You ship the product to the customer deploys it to production and starts using it. Everything looks fine so far. until the customer starts receiving complaints from their users saying, hey, I was trying to redeem my brand new gift card, and your system says that it's already redeemed. So there is an escalation ticket. You start digging into everything. The good thing is that you're responsible. You have logs in your production environment, and you start looking at the logs. And what logs show you is that if there are two concurrent API calls to your REST API that create new gift cards, then it is possible that they will return the same ID. This is not how it's supposed to work, and that's why the second gift card becomes redeemed. So you start working with the Oracle DBA on the customer side, digging into the queries, digging into the internals of Doctrine DBAL, and you find out how it works. So in order to get the value of the auto-generated column, knowing the sequence name, Doctrine DBAL just calls the queries the status of this sequence and basically fetches the current value of the sequence. So if the two concurrent calls first make two inserts and then make two fetches, of course those two fetches will receive the same value because sequences are not scoped to the connection as this API implies. They are global. They just exist as tables and everything else. So that's how it works. And after consulting with the DBA, you figure out that this is how those queries should be written for Oracle. Oracle and other databases like Postgres and probably SQL Server, they support this syntax returning something into something. So basically, an insert statement can also return the final values of the columns that it has inserted, including all the triggers, all the operations that happened internally. So in this way, you can get the auto-incremented ID. So again, you end up rewriting your code and adding this ugly instance of statements. So if it's Oracle, you have one path. If it's not Oracle, then it just works as it did previously. So to sum this up, here's what the leaky abstraction in this case. On the one hand, different implementations of the same API within the same library have different meaning. Like even though last insert ID is supposed to be scoped to the connection, sometimes it's not. And eventually, you as a user cannot use the API as is. You need to introspect the state of your application. Hey, what is that I am connected to? And then write it this way. So how can you mitigate that? The first thing is that if you really, really, really need those auto-incremented value, just use custom code. But if you can avoid them, you probably want to avoid them. You can generate values on the application side. They could be UUIDs v7. It's beneficial for other reasons, but this way you will just not delegate the application logic to the database. You will do the ID value generation yourself. So another feature that Doctrine DBAL provides in the driver layer is the blob columns. Effectively, it's a way of storing files in the database tables. So you have strings, numbers, and files, just like that. So, and what's special about the blob type is that, unlike all other types in the database, it's really, really huge. So it's not ones of bytes or dozens of bytes. It can be terabytes. So when you write your code that deals with normal types, you can store them in memory. You can store thousands of them in memory, but you cannot even store a single blob in the worst case scenario. So for that, Doctrine DBAL and the underlying drivers represent blobs as streams. So a string is a PHP type that allows you to deal with huge values, effectively like even endless values, by dealing with a small chunk of the value at a time. So if you want to insert or update, for that matter, a blob into the database, you execute a statement, and instead of passing the value of that blob itself, you pass a pointer to the stream, or the stream handle. And the driver will read the stream into the database. The same is the other way around. If you want to fetch a blob from the database, the driver will give you a stream, and you can read the stream into whatever you want. For instance, you can output an image into your browser. So the design here is that the part that is reading the blob is in control of the code execution. The reader is the boss in this case. So let's say we want to implement a medical information service with like a simple REST API, something that allows us to store images and retrieve images. Very simple thing. There's even not, we don't need the code for that. We can implement this simple API, start testing it on MySQL and Postgres. You can upload the images, you can download images, everything works fine. And then the next requirement for you is being able to store large images, for instance, CT scans. So when you start testing it, you will see that you can upload huge images to a MySQL database, but you cannot download them. And with Postgres, you cannot even upload them, and even if you could, you couldn't download them. And in all these use cases, the problem is the memory usage. You just run out of memory. So if you look at this problem holistically, then the problem is not only about MySQL or Postgres, it's about all the databases that Doctrine DBAL support. So if we look at the horizontal rows in this table, there's no database that supports both reads and writes without memory overhead. It's either this or that, and in many cases, the memory usage overhead is not only comparable to the size of the blobs, it's twice as much or even 5 times as much. So why is that? First of all, the problem is that the MySQL driver for PHP does support writing data into the database as streams, but it doesn't support reading, just the driver itself. So in order to sort of bypass that and save its face and still represent blobs as streams, what the DBAL does, it just reads the entire blob into memory and then represents it as stream. So basically, it annihilates the benefit of dealing with blobs as streams just because the driver doesn't support it. As for SQL Server, the driver does support fetching blobs as streams, but in order for it to act like that, you need to specify that, hey, I want to fetch this specific column in a stream format. And Doctrine DBAL doesn't support specifying that. There's just no API for that. So it defaults to reading blobs as strings again. And that's, as a side effect, again, memory usage overhead. If we look at Oracle, it's different. So unlike the API design in Doctrine DBAL where the reader controls the flow, Oracle provides a different API for dealing with blobs. It's very powerful, but it makes you the one who should control the flow, both in the read and write scenarios. So if you're writing a blob to the database, again, there's no API for that in Doctrine DBAL, so it defaults to writing them entirely as a string. And as a result, there's memory usage overhead. With Postgres, there is a totally different picture. Postgres does support blobs, and similar to Oracle, it provides a powerful API for that. The problem is that blobs in Postgres are not a column type. It's a separate type of objects in the database, like you have tables, columns, views, and blobs. And what Doctrine DBAL uses for blobs is the byte A type. And byte A is just a binary string, and there's no streaming API for binary strings. So again, DBAL just uses strings everywhere. As a recap, basically it doesn't work anywhere. It shifts the responsibility of dealing with streaming large files to the user. The good thing is that all those drivers support proper APIs for dealing with blobs, and you as a user can just implement storing and fetching blobs yourself as your use case requires. Another approach is, again, to avoid using blobs at all and using something like a blob storage like S3 that provides scaling and all other features that your product may probably need. So another type of database abstractions that Doctrine Debal provides is the type abstraction. It basically maps your application types, like string, to the database-specific type, varchar or nvarchar or varchar2, depending on the platform, so you don't have to deal with that yourself. Let's say we want to implement a sort of domain name service. So it does domain name lookup. You give it a domain name. It gives you the IP addresses. It can do the other way around. And the third endpoint is basically you may want to query domains by an IP address mask. And of course, you want to do it as a, again, portable software product. The good thing, so the thing is that in order to do the first thing, the first two API calls, you could just get away by storing IP addresses in the database as strings. So it's just key value mapping. But for the third operation, you need to do some binary math. You need to basically scan your table and do the math, whether or not this IP address matches this mask. And for that, you want to operate on them as integers. So the good thing is that PHP already has the API for conversion of string IP addresses to integers and back. And you just need to store them in the database and then do some query on top of those integers. So the type that PHP represents those IP addresses as is unsigned 32-bit integer. And what unsigned means is that in unsigned types, the underlying data structure reserves 1 bit for the sign and only uses the rest of the bits, like in this case, 31 bits, or in this case, it's 7 bits for the actual value. So the number of unique values that both the signed and unsigned type can cover is the same, but the range is different. So we want to represent unsigned 32-bit integers in the database. So we create an integer column, and we use the unsigned option for that column, and we start writing our code. So again, as in the previous example, we have prototyped the code. We start testing it with different domains, with different IP addresses on MySQL. It works fine. We start testing it on Postgres. Sometimes it works, sometimes it doesn't. So what's the problem? The problem is that if we look at Doctrine Debal and look for the unsigned word, we only see that it supports unsigned for the MySQL database. And it pretends that it supports it for SQLite. The problem is that no other database platforms support unsigned types at all. So if we look at the error message here, when we try to insert an integer which is larger than like the half of the signed range, it will fail on Oracle, and that's why it doesn't work. So what if we still need to support that? For that, as a workaround, we can do our manual conversion of the signed integers to the unsigned and back. So in our application, they will look like unsigned, but in the database, they will be stored as signed. You can do all the binary math, but at the same time, it's all absolutely transparent. So the last abstraction I want to cover here is the schema and query abstractions. Databases, the relational ones, they make us define schema and queries basically as strings, and it's really inconvenient if your application is highly dynamic. You want to build the queries on the fly, you want to build the schema on the fly, it's really inconvenient, but there are APIs for that. So again, let's say we want to implement a software product that creates a business engine, business process engine, and it has the notion of rules. The rules have the ID, the name, and they have the flag ignore. If ignore is on, then the engine should ignore the rule. Here's the business requirements. So we have prototyped that. We want to test our business engine with some rules. Some are set to ignore true, some are to ignore false. We start testing it on Postgres, and we can confirm that our database schema can be successfully deployed to the database, and we can create test rules. That's fine. If we start testing it on MySQL, we can also create a database schema, but we cannot create rules. And when it fails with some cryptic SQL syntax error. So what the problem is in this case is that on MySQL, ignore is a keyword. It means that the insert operation with this keyword should ignore all the errors that are happening because of the violation of different constraints, for instance, like unique constraints. So, but the other question is, OK, if it's a keyword, why didn't it fail during the schema deployment? Why did it fail only during the insertion of the test data? And the reason is that the schema manager in the debug that is responsible for schema and the query builder that's responsible for building queries, they imply different semantics for column names. In schema manager, column name is really a value. So whatever you call it, it's responsible for making sure that this column is created exactly as is in the database. And if it's a keyword, if it contains white spaces or some special characters, it will escape and code everything and make it created as you expected. While the query builder is a very low-level abstraction. It's basically a string builder. You can put anything in. It will just concatenate all those bits and produce a query. So in this case, when you're querying, or for that matter, inserting a column with a keyword named as a keyword, you're responsible for quoting it. But again, it's not really obvious, and it may or may not work depending on the database and the names that you're using in your application. So how can you mitigate that abstraction leak? The first obvious advice, similar to the previous ones, do not use keywords. Use something else. But the problem with this approach is that you, as a user, you don't know what's a keyword and what's not. For instance, in MySQL 5.6, you could use a column with the name rank, and it would work fine. But in MySQL 8, rank became a keyword. So you didn't change anything, but your application stops working just because of the upgrade. So the other obvious example is try enforcing quotes around your names. So you can use basically anything, and with the only exception that the semantic of adding quotes around the name depends on the database platform. And the SQL standard, ANSI SQL something something, says that if the name is quoted, it should be case sensitive. Otherwise, it should be uppercased. So databases like Oracle, if you quote a keyword, and if it's a lowercase keyword name, it should remain lowercase everywhere, and quoted. Otherwise, it will be automatically uppercased. So that's not a solution either. There is only one ugly but bulletproof solution. Prefix your names with something like T for tables, C for columns, V for views, and something for something. And this way, you'll make sure that nothing is a keyword. But it doesn't look good. The last thing about the database abstraction leaks in Doctrine Debug is Doctrine Debug itself and how its APIs are done. So there's these many methods that basically, by their existence, violates the tell, don't ask principle. The principle says that you should be able to tell the other thing what to do, not ask how I should do it. This way, the implementation of the API will encapsulate all the details to itself and just do what it's supposed to do. But Doctrine Debug exposes the methods like this database supports that or it doesn't support that, whether it uses something or doesn't, whether it prefers something or doesn't. This way, it shifts the responsibility of implementing the behavior to the user itself, which is not nice. The good thing is that about a half of these methods have been deprecated in DBAL 3 and will be removed in DBAL 4, and the rest is to be done. Enough about the examples. Let's get a little bit philosophical about how did we get there. So Doctrine DBAL, according to Packagist, is the #1 database library in PHP. So how come that it has so many sort of API deficiencies or defects? The leaks I showed you are not the only ones. There's way more like that. How come that people are still using it? Why aren't they using something better? The most obvious answer to that is that, well, it's good enough. It solves many different problems well. It enables people. People are mostly happy, and what I have just shown are really the corner cases or edge cases that have workarounds. So it's popular despite its API flaws. The other less obvious observation that we can do based on that is that Doctrine DBAL is flawed because it's popular. And I will need to elaborate on that a little bit. So a general purpose database abstraction is just a multi-tool. It's something that can perform different functions. Those functions are not really tied together. You as a user can use one but not use the other. And as in this picture, these tools are not the best you can find, but they're good enough and they come together. And you can just get used to using them as is. On the contrary, this is what a specialized database abstraction may look like. By a specialized one, I mean something which is, let's say, a proprietary DBAL, for instance, or proprietary or something that is specific to a given project. Let's say you have an engine like WordPress, and it may have its own database abstraction layer. It doesn't have to implement all the general functionality that anybody in the world can expect. It can implement a very narrow subset of features which reduces the risk for abstraction leaks. And at the same time, it must implement them well, because if your product depends on the certain API working correctly with all the database platforms that you support, you have to make them work properly. So otherwise, let's say if your user login scenario depends on something that doesn't work as expected in your database abstraction, it's broken, and it will have to be fixed right away. So my general observation is that specialized abstractions, even though they are not nice from the code organization perspective or something, but they have way fewer database abstraction leaks. And if we look at a popular general purpose database abstraction, which Doctrine DBAL is, it's that. So what happens is that it tries to support as many possible scenarios as possible, and people who start using it, they always find something that's missing there, and they try to contribute that missing feature or do something else, and basically it just grows uncontrollably. So let's see how we can deal with that and what we can do about that. As a user of an abstraction and a database, and as a developer of an application, you just want to use your database as a dumb store. Basically, use something very simple like tables, columns, indexes, foreign keys, something that works well enough everywhere. If you need some business logic, like generating columns or anything else that belongs to your application, implement it there. You can use advanced things like triggers, views, or something temporarily as a means to migrate your data from one version of your application to the other. But as soon as you're done, you will need to remove them. Otherwise, you'll have a hard time making them portable, it's virtually impossible. The other thing is that if you really want to implement something portable and something that doesn't exist in Doctrine DBEL or any other general purpose library like that, you may want to consider introducing your application-specific abstractions. For instance, there have been quite some efforts to implement upserts in DBEL or, let's say, batch loading of data. The challenge is that it's virtually impossible to implement these features with the full set of requirements, working with all drivers on all database platforms, with all column types in all scenarios. It's really hard. So what you can do instead, if you need that, you can steal the database connection from DBEL and introduce your own interface. For instance, you have like an upsert something interface, and you just implement it to the extent that your application needs. You will not be able to contribute it back, but you will be in full control, and you will make sure that this specialized, highly specialized database abstraction works as necessary. So as for testing, I've seen quite some code bases that actually mock the database connection, or for that matter, they mock external libraries. And it's never a good idea. For instance, those tests, what they do is that they mock the database connection and make an assertion that my controller should have performed this query. And if that's the case, the test passes. First of all, the fact that the test expects this query doesn't mean that this query is correct, because it may be specific for the database platform. And such tests, where you mock database connections, they really create a false sense of safety. So you have some decent code coverage, but when you want to, let's say, upgrade your database to a new version, well, you have to test your application manually, because your tests don't even connect to the database. So that's not the best idea. A better idea is, again, to introduce your own application-level abstraction. For instance, if we want to store something in the database, we introduce a repository interface. We implement it with a general-purpose database library. And now we can mock our interface. So instead of saying that my controller should have made this query, we are writing the test that says, my controller should have called this method with these parameters. So it's really your concern how they two communicate, because you own them both. Once that's done, you can do integration testing for the actual implementation of that interface, and make sure that it does work to the full extent in all configurations that your application support. Besides mocking the interface, what you can do is faking it. So faking is basically creating a simplified implementation of your interface. For instance, if we want to fake a database, we don't need to implement anything like scalable, fault-tolerant, and durable. We can just create an in-memory storage that can accept the calls to store an object and fetch objects from that in-memory store. And after that, you can integration test your business logic with fakes, so it will have the benefits of being fast enough, because it doesn't require any interaction with the external services. And at the same time, it's reliable enough. And you can even reuse the same tests, so it's benefits of the both. And this is it. Please rate this talk on LinkedIn. Again, LinkedIn. Join in if you found it useful. If you found it useless, please rate it as well. And happy programming. Are there any questions?